this week's class, and we're going to be mainly doing SAS stuff for this week. And I do have to warn you that Thursday's lecture is going to be kind of harsh, and there's material up right now on the blackboard to read beforehand, so I would highly advise looking at the material beforehand, before the lecture on Thursday, because we're going to go over diversity on Thursday. Today what we're going to do is some basic SAS stuff, but before I want to do that, I want to kind of go over the project that's due. Paul said I did it, and I sort of did, but when he told me to talk about it, he said, oh, don't mention it, just say it's important. But if you've noticed that there is, the project requirements is up on the blackboard right now, and it was posted on one of the first days of class, because I want to kind of bring your attention to the fact that on the 3rd, your proposal is due. And then there's going to be a little oral report in class. So that's coming up quite quick. So you need to put that on your schedules of things to do. And going through this proposal requirements, if you have not noticed yet, Paul is really, really particular about everything. He's very, and so when he writes these requirements of what you need to do, make sure you do all that. Like when he says put your name on the top of the sheet and all that kind of stuff, I think I made that mistake one time and I got chewed out for that. So you gotta really make sure these little things, he's very, very particular about these little things. So basically for the 3rd, you need to have your written proposal and a 5-minute oral presentation about it without PowerPoint. Okay, so by that point, then you need to have picked your data set. You need to kind of have an idea of what you're going to do. So he said this is an example of what the proposal will look like. Has anybody actually looked at this document yet? It's on Blackboard. Like 1 or 2? Okay. So in here, he actually shows you exactly how he wants it. And I would have it exactly like that. I mean, each line is where it is. He's very, very particular about this stuff. If anything that you lose points over on Paul, it's to follow the directions on his assignments. Okay. All right. So anyway, I would put that on your list of things to look at. Okay. Because I probably won't mention it again until we get closer in, because we're just going to be focusing on SAS for right now. Any problems with doing the assignment? That anybody had? Everybody got it in? Did everybody get it in? I know somebody emailed me about that they tried to redo it and it wouldn't work, and they wanted to do it again. And I think he's allowing a couple of tries on it, and that's the online system. But I wanted to mention that for anything grading or anything that comes to do with grades or the assignments, really needs to go to him, because I have no say in, hey, would you let me take this late or anything like that. So if you're going to do an assignment late or have an issue with grading, talk to Paul. If you need help on assignment, especially this week, he's not going to be here, so you can ask me for help. Okay. All right. So what we're going to do today is we're going to be looking at that NAS1 file that you did the live name statement for. And the goal for today is we're going to use SAS to find the richness of species per core out of that data set. And we're going to try to make a little graph out of it. So that's a very, very SAS basics, but it's going to be pretty powerful, because the stuff that we're going to do in SAS, it's impossible to do in Excel. And we could do it in maybe 1 page of code. So to give a little background again about this file, so I'm going to open it up, the study that Paul did. I've only got one color, unfortunately. But what the study is they wanted to see the effects of a sewage outflow on benthic diversity. And so if you've got, let's say, a whole island, this is NAS island, which is right over here. So our campus is over this way, and there's a sewage outflow right here. And the study design was, let's take a transect. So a transect is just a straight line fieldwork study. So we're going to have one transect ray. And every so many meters, we're going to take a sample. So in this sample, we take at 0, so we take a sample here, there's a station here. Then we take it at 10 meters. And then we go another 100 meters and take a sample here, and then 1,000 and 2,000. Okay. Does that make logical sense, what we're trying to do? This is all in one day, so the date is just the one day. So in one day they took the boat out and they hit all of these stations. And inside each station, when they roll up to it with the boat, and there's this big pole with the core, and they punch it down in the water to take cores out, they took 3 cores. So there's 3 replicates. So what that would look like, say if this is the bottom, the mud, and up here is the waves, and you've got your sample boat right here. Try not to make fun of my, I'll make it a sailboat. Okay. And so they put the core out, and they take 3 cores of mud. Right? So here's our three individual cores of mud. And inside those cores, there's going to be species of benthos that we're going to count. So I'm going to draw a couple of species here. This one's only got 1, this has got 2, this has got 3. Okay? So inside that replicate, there is a mean, right? There's multiple species in the mud, but not all the time when you put the core out are you going to find every single species in every single core, because they're a few feet apart, and it's a random distribution of what species you're going to find. So if we look in the data set, in this macrofauna folder, let me see if I can blow this up a little bit. Okay, that's really good. So here, this is the date they went out, 1994, and let's just say we're at the first station. So we're at this station right here, right by the outfall. All right. So we'll highlight these 3. Okay. So each record in the row is a species. That's a species code. And since there's so many species, they have to define a code for them, because there's almost like 1,000 species in the area. So we found in the first replicate core species 81, and we found 1 of them. Okay? And now in the same core, we found species 303, and we found 6 of those species in there. Now this section, in reality, they actually section the cores in half, but just for the class, to make things easier, you can just ignore this row, because it's the same section. Okay? But in reality, they have different sections where they take the core that's this big and they cut the first few inches off and count that separate to the bottom side. So you actually end up with, well, out of 1 core, you've got stuff off the top section and stuff off the bottom. That's just to see, well, are they moving, and the different things in between that. But for this, we can, in fact, let me just go ahead and just delete it off of here, then I don't have to worry about that. Okay. All right, and now this number, this nm squared, if we come back to the metadata, it'll tell us what this is, or it should. Number of organisms per meter squared. And that tells us what that variable is. So basically all you do is you take the number of organisms per sample and you multiply it by meter squared. And so that's the average that you would find of that individual. Okay? So it's just the same number, it's multiplied by a constant. So now we're looking again at just one station. Let's just focus on this one station. So there's 3 cores. This core number 3, the core number 2, and core number 1, right? So the first core, we only found two species in that whole core. Species 81 and species 303. So the richness of that core is 2, right? We only found 2 species. So the richness is 2. Okay, and now this core, well, we found quite a bit of different species in this. We found a species 81, found 4 of those. On core 2, we found species 303, found 14 of those. 167, 1 of this species, and 1 of this species. So if we count how many different species we found, 1, 2, 3, 4, 5. So our richness in that core is 5. Okay. Now this last core, we found 3 different species in them, right? So our richness is 3. So if we're looking for diversity at site 0, at the first site, we've got 3 different answers for each core we took. One core said, well, we have a species richness of 2, one was species richness of 5, the other one was 3. So the task for today is, can we use SAS to do this procedure we just did, but over the whole file? And I want to graph this out and make a table graph to say the richness of cores per station for all the stations. Okay? So does that make sense? I mean, it sounds like an easy task to do, and you could sit there and do this in Excel, but you could see that you would be doing this by hand, right? I mean, it's not intuitive how we would do this in Excel. And if you had to do this, you know, for 1,000 records, it would get to be a tedious process. So this is the whole point of why we're going to switch to SAS. Okay. Any questions so far about that file? Kind of what we were doing with that study? People actually read the. If you read the study, things really make sense too, because he had the study as part of the. It was in the Dropbox, or was it one of those? He put it somewhere. No, it's in the file, in the metadata. That's the published paper. So if you look at it up too, the study will make quite a bit of sense. Okay, so now we're going to switch to SAS. And the homework assignment was take that file in and convert it to a SAS database and put it on a file folder, right? So hopefully we've done that. And let's see, this is my SAS. So when I log in and go to the Explorer, I don't see anything, right? So I haven't done my live name. I don't have the folder in. But what I did is I saved it in this program. So that's my libname folder, right? So that'll let SAS know where that file is. So I run that, and now I have this folder. And here's the data set. Okay. So we've all kind of got to that point, right? Is there anybody that really hasn't got to that? Okay. All right. So now we've got it in SAS. Now we actually need to do something with it. And the functions that we're going to go over today, and there's 4 main functions, and really a couple of them are just the bread and butter of SAS. And I can tell you right now, once you start learning, like, it's sort and means are the 2 biggies. And once you've really learned how to do that, you'll find yourself putting stuff in SAS just so you can sort it and just so you can take a means, because it is so easy to do this in SAS. Okay. All right, so I'm gonna leave that because this is what we did by hand. So now we want SAS to do this. All right. So I'm gonna get a new file, and everything I'm gonna type up, I'm gonna save. I don't have the wireless internet working on here because I've never really had the use for it. So when I get back to the office, I'll put it on the blackboard. Okay, so the file will be there. So everything I type up right now will be there when we get back to HRI. I'm going to save this, and I'm going to put it in my folder. My class folder. Call it NAS Basics. I don't think it worked. For some reason it's not letting me save it. Alright, hold on a second. I don't know why it's not letting me save it. Oh, I'll just copy it later. I'll let that go. Alright. So the first thing we want to do is sort our table. Okay? And when I mean sort it, in Excel you can sort by a column and have all the other columns line up where they're supposed to go, right? So if I wanted to sort this by replicate, then you could say sort this column by replicate, so then you'd have all the records with 1, and then you would see the 2s, and then you would see the 3s, right? Or you could do it by species or number. The problem is what if I want to sort it, I want to sort first by date, then I want to sort by station, then I want to sort by replicate, and then I want to sort by species. What if you want to do a layered sort like that? And that's a very easy process in SAS to do. So say, and the procedure we're going to do is called Proc SORT. So this is the procedure, and I'm just going to build the basic one right now. Okay. So with any procedure, at the end of it, you're going to have a run. And this tells SAS that everything in between here and here is part of that little code section. In other code languages, like if you've ever programmed in, well, basically anything, there's a curly brackets or things like that you can denote a block. There's nothing that cool or awesome in SAS. So this is really like Fortran from 1977 type of program structure. So the only thing you have is, well, if there's a run here and everything between here would be it. And I can guarantee, like if you forget to type the run and then you have another block you wrote down there and forgot to put this run, it thinks that whole thing is part of it, and so then you'll have an error. Okay? So you just have to kind of visualize it that this is where we're going to be working in. All right. So first thing is I need to say what data set we're going to sort. And we use a keyword, say data equals, and as I type and it becomes blue, SAS is recognizing that as a special key name. So you know that when it's blue, you know that, oh, it recognized it. Okay? So data equals is a key name. And what I might do, actually, is I'm going to make a little table right here of key names and kind of what they do. Data. So data will specify the input we'll specify your input data set. All right. So I want this NAS1 file to be my input. Okay. So to do that, I need to tell it the folder it's in, and then the file. So the folder that I have on my computer is in this XP DES. So if I go up a folder This is what I called it. Now, what you named yours is going to be different, right? Whatever you named your folder that you have. So I'm going to type XP does, and then I'm going to type period. And you see the minute I type the period, it changed colors, and it recognized that the first part's going to be the folder. And then now I'm going to type the rest of the set, NAS1, okay? So again, the first part before the period is the folder, and the part after that is the file, okay? So it specifies the input data set in file.folder. So if I didn't put a folder and I said just NAS, then it's going to think it's in my work folder. That's the trick of SAS. If you don't specify a folder, it's assuming it's work. It's assuming it's in that work folder. And we're going to use that work folder in a minute because we don't want to mess up our good file, right? So SP does period. All right. Now that I've got the input, I'm going to specify an output file because I don't want to mess up my good data, right? I don't have to import it again. So, and to do that, there's another keyword, out equals. So out equals. Specify the output data set. And folder file. Okay. So now I want to have, when this procedure is done, I don't want to change the original file. I want to make a copy of it. So I'm going to sort it and make a copy of it and put it in something else. Okay? So what I want to do is I want to leave that in work, in a temporary file. So I'm going to make a file, and I guess, and again, it doesn't really matter what you call it. I'm going to say macro fauna, and then I terminate the line. Okay. See if I can make that any bigger. Can I make that any bigger? There's a way to do that. I guess there's not a way of doing it. I thought there was. Nope. Okay. Can you see it, or
I can't see crap.
you can't see it?
Maybe the box.
Yeah.
I do have a question.
Okay.
If you would possibly want this data sorted, why would you not just save it in your regular folder so you'd always have it? Because,
Yeah.
I mean, granted, I guess it's not that big of a step, but then you could skip a step the next time you wanted to use it or graph it or whatever.
Well, it's true. But there's actually, that's a really good question because depending on what analysis you're going to do, depends on how you're going to sort.
Okay.
Because if you do an analysis, a means on a replicate, you have to sort it one way. If you're doing the means on species, you have to sort it another way.
Okay.
And so when we get to the means procedure, the next procedure is the means, and SAS expects it to be sorted in the precise order it wants, depending on how you do the means.
Okay.
So there's that. The second reason is, what if you type something wrong and mess it up? Yeah. So there's that's the other problem. Okay. So this gives us their input and output. Now we want to tell SAS how we want to sort it. And to do that, there's a statement called by. And the by keyword, it says an order. By gives, and because by is used in multiple things, not just proc sort, but it's specifying the order of hierarchy. So to say that I want to sort by, first I want to sort by station, and then I want to sort by rep, and then I want to sort by species. So it's left to right in that, okay? And we're done. So to execute this, you could do either one of two ways. Since there's only the one thing in the whole file, if you clicked anywhere in it, doesn't matter where you're clicked, and you come up to this little guy, this little running guy right here, and it'll submit the whole file. If you just want to submit just one statement, you can select just the code for the one statement and hit the little running guy, and then you'll go. Okay, so we're going to run that. And then we go up to the log and we'll see what happened. Okay, so it says what we did, and there's still 48 observations. Should be exactly the same, right? We shouldn't get rid of anything. But it's not in my class folder, right? So where did I put it?
Work.
In work. So let's go up. Okay, and let's look at it. Okay. So now we should be sorted. Date doesn't count, it's just one. So it should be sorted by station, rep, and then species. Okay? Does it look like it's sorted like that now? Okay? So to kind of maybe drive it home here, let's close. We got to close them if we do something new to it. So say, what if I just sorted by rep and species? And what do you think would happen if I just did that? I mean, it depends on what we had previously. Okay. If it was not sorted right. So now we're sorted by rep and species, right? So again, it depends, that by statement depends that hierarchy you want. So you put the very top end, the left side, and then further on the right. And so whenever we do any analysis at all in SAS and you use that by statement, that's the hierarchy you use, okay? So we could even go even further. You could say, well, sort it by species and then number, you know, or however else you want to do it. Let's go back and let's change this. And we're going to say station, rep, and species. So the question is, how do I know STA means station? How did I know that that is what that means?
Your column name is.
It's the calling name, right? So when you go back in your file, now let's open it up. That's the name of the row, right? STA. Later on in the class, we'll get to making that a fancy label. So it's something fancy when we print out a graph. But for right now, that's the row name. STA, REP, SEC. So if I wrote station STATION, then it wouldn't know what that is, right? So it's just going by the row name. All right, so now that we're sorted, now I want to run a means, okay? Now what I want to do is, and a means essentially collapses these records together. It'll do what we did over here and take all the replicates, and so now I only want one record row per replicate, okay? So I want to know the number. So let's look at it again. There. This to the side. I'm sorry about being small. I'll try to figure a way of making it bigger. All right, so the next procedure we're going to do is called Proc MEANS. Proc MEANS. Okay? And in this, I got to tell plus 8. No, is that 3? No, plus 1. And then the third core would be 8 plus 10 plus 1. I want to count that too. Okay? That's the total number of species. So what I want to do is sum those together. So since I said focus on this variable n, that's the variable we're going to focus on. All right? And now what I want to do is present out the sum of that. So I tell SAS sum equals, and then the variable name. So here's another keywords. I can erase these two right here. So say var focus. And that's the variable we want to do an analysis on. Okay? And then down here, sum okay. Now we're going to sum, and we want to say which one we're going to sum. So we have to have those line up. So say if we wanted to sum the species codes, you could sum the codes, but that wouldn't really help us because those are codes. So we'd end up with some weird number we wouldn't know what to do with. But if we sum n, then we can sum the number of species that we found total, regardless of species, right? Okay. So now let's run that. And I did something wrong. So let's see. Okay. It says data macrofauna is not sorted in the ascending sequence. This is what I was talking about, having to sort everything the correct way. So the current by group has this station and the next one has that. So we need to sort things correctly. Let's see. I need to run this again maybe. There we go. I had to run it over again. Okay, so we look at the log. This time it worked. Because I was messing with the file before, so it wasn't sorted. So now that it's sorted, it can run it. So that's the question we had before of why do we not want to sort on our main one? Because depending on what you do for a proc means, depends how you're gonna sort. Okay. So now it says we read 48 observations from the data set. That's what we had before, right? 48 rows. But now the new data set only has 12, right? Because what we did is we collapsed all the species rows out. So they're all gone now. So now if I go back and look, okay, now we end up with this looking table. Where now we have the stations and replicate. So there's only 3 rows per station. So we only have 1 row per core now, right? And we have this thing called type, which is just a leftover from the procedure. We have this thing called frequency, which is produced from the procedure as well, that's got numbers in it. And also this n, which is what we wanted. So if we look at this frequency, it looks suspiciously like this frequency, right? So that's what it did, is it counted which rows we collapsed out and counted, well, how many rows did I collapse? Well, I collapsed 2 species, right? And I put that number there. And then the total number that I found over across all of them was 7, because I added all of them together in the sum. Yeah, this is hard stuff, right? Does that kind of make sense of what we're doing to the data? Now the procedures and stuff, I got to tell you, you've got to look at the manuals pretty much every time you do something. I mean, even Paul does, even I do. But we really need to focus on this to make sure we understand what we did to our data. And now we understand what we did to get this. Because just getting this, try to do that in Excel. That would be a bit, you know, to do that, and it's already done. Okay, so another thing is it did print out this, if you notice this came up, this little stats. So the means procedure prints out stats, and a lot of procedures do this. They'll print out some stats, and sometimes you copy and paste them in your paper, or it gives you, you know, this is what it was. We really weren't interested in this. All I really wanted was the data set. So whenever I run this again, I don't want to see that. I don't want to have that print out every time. So there's a special SAS keyword to get rid of any time that it prints something up. That's called no print, oddly enough. So in the first line, if you say no print and it turns blue, no print, no print will work on basically any SAS function that prints something out to the results, that prints an HTML page out. You can put that on any one, and what it does is it suppresses it. So if I didn't have an output, if I didn't have this output line, we would get nothing out. We wouldn't know anything about it. Okay, it would just run and then it'd be done. Okay, so now if I run this again, let me close all of these. Then it shouldn't print that out anymore. Okay, so now it didn't print that out. So I ran it, it didn't do anything. But it did execute, so because if I go to the log, and it's there. So if I can run this again. So it runs, but now it doesn't print that stuff up. Right? So it just kind of saves you that. Okay. So this was really the hardest part of this whole thing. Now that we've got this table set up, I mean, we're basically halfway there. In fact, all we really need to do now is do a little bit of cleanup, and we can print this thing out. Because this is what we wanted. I wanted to find out the frequency, that's the richness. I wanted to also find out the total number of individuals per core, regardless of species. Now I want to graph this, but in order to do it, I want to fix my variable names, because I don't want it to print out and say underscore freak underscore. I want it to actually say richness, okay? And it's difficult in SAS to just go and right-click these things and rename them. You have to do it in data steps. So now we're going to go and do a little bit of fixing up, okay? And also what I want to do, now that I have this done, I want to make it pretty, and then I want to save this set in my, not away from work, but in my real folder for the class. And I'm going to make this composite data set that I'm going to store forever, now that I'm done with it. Shoot. Okay. I'll put this over here. We can kind of look at it while we're doing it. Okay. So in order to mess with data sets and do any kind of data cleanup or getting rid of rows, renaming things, that all has to be in a data step. You can't do that in a Proc MEANS, a Proc SORT, any of the procs. Those are procedures to do some sort of statistical analysis. The data step is the step that you do for your data manipulation. And so it has a different whole flavor of logic that you can do in data steps. And so that's what we're going to start doing right now. So first I'm going to say data, and that's the data step. So I'm saying this, I'm now going to do a data step, and I'm going to put a run down here, again, so I don't forget that that's my block, my code section. Now I need to tell it which data set to open up, and it would be really, really nice and convenient if I could just do data equals like everything else, but of course it's SAS and it doesn't work like that. So the way that you do a data step is you say data and then the file. So you don't have to do data equals and all that. They don't have that on there. So what I want to look at is NAS. Again, because it's in my work, so I don't need to put the folder name there. If you want to, you could just say work NAS. Okay. It would work just as well. Actually, scratch that. I'm sorry, I'm telling you wrong. You put, on the top, you put the in file. Okay? So the in file I want is a composite data set, so I'm going to say NAS composite. I'm sorry, I told you the wrong thing. The data step, the top line is where it's going to. And inside of it, then you have to do set. Set is the data step keyword. Keyword for input data set. Yeah. It's confusing to me. Okay, so I know everybody's confused. This is SAS. Yeah. But that's the way it is. I didn't design it. There you go, print. Okay. So you only use set in a data step. It never goes anywhere else. All right. So set work NAS. All right. So what I'm saying is I'm going to have a data step. This is my input file, and that's my output file. And it confuses me because it doesn't make a lot of sense compared to the other ones, right? But that's just the way they wrote it. So we just got to remember it. I'm sorry. Okay. And in fact, what I can do in this file, I can do something like this. Okay. I'm going to put little comments. If you can see it. In SAS, if you just do this star, that comments the whole line. What I want to do is I want to set a comment that could be multiple lines or just a chunk of a line. And the way you can do that is a /* and then the star / at the end. So everything inside that's a comment. Okay? I wanted to make sure to show that to you today. So that way I can say that so we don't confuse ourselves. And then I could maybe add some extras otherwise. No, I guess it's not as easy. Okay. So now that I'm ready to work in this, so I'm ready, it's ready to receive some commands and do something to that file to create that file. Right now, if I run it, there's nothing in here. So what I could do with this is actually just make a pure copy. This is the way you can actually move things around folders. If you didn't even want to touch the file at all I want to do is make a copy and move it to a folder. And so this is how it would be. And so if I wanted to just take a copy, and I want to take, because this is from work right now, this one in my work NAS, I want to save this without doing anything to it. I want to save it exactly like it is to my class folder. Okay? This is all I would do. So if I run this, and I actually have to close this too to do it. Okay. So now I've executed that, and it said 12 observations read from my work.nas, and now 12 observations in my experimental design.nas comp. Okay, just made a straight copy. So if I look it up, then that's there. Okay, that's how you copy files. But now what I want to do is I want to fix this thing up a little bit and do a little messing around. In Excel, for one thing, I want to delete this. I want to delete that. I don't want to save this type. In Excel, all you do is just click the row and say delete, right? But in SAS, we have to use a command to do this. So what you do is inside this data step, I'm going to say drop. Drop. Okay. So drop. Okay. It deletes the column.
Could you do it for row? Or is it another command?
No, to pull out a row would be different. We have to use some logic. That's tomorrow. Even harder. Because there's multiple ways to do that. Because what you're saying is, if I wanted to delete a row, I could say, well, I want everything but this station. You can do that. You have to do that with a conditional. So you say, if station is equal to this, then delete would be how you do it. Again, that's tomorrow. Or you say, save everything except, you know, if it's replicate 1, save it, otherwise everything else drop. So you have to do that differently. But for a column, you just say drop. So that just deletes that column. Okay? So let's run it. And again, I'm having to always close the table open, because often if you have the table open, then it won't work. And it won't be able to read it because you've locked that file. You've opened it up. And so in Windows Explorer, it says that file's locked now, you can't open it. And so if you have multiple people working at the same time, this stuff happens. This is the other reason in the office that we always make copies of stuff. We never work with the master file, because if you open it up, even just viewing it, it's now locked, and you can't open it up. All right, so let's run it. Okay. In fact, maybe we'll see the different. Okay, so up here, the last time I did it, it said 12 observations in 5 variables. Now I ran it again. It says 12 observations in 4 variables. And if we look at it, okay, now we've dropped that one we don't want. We don't want that anymore. Okay. So now what I want to do is I want to rename a row. Because I want to rename this. And this is actually richness, right? So I want to rename that row, and we save it. So we do that is rename. And the way that you label richness is either an R or an S. So I'm going to use the capital S for richness. And so you say rename frequency with the underscores equals capital S, and then terminate the line. So now it's going to rename that. Okay. Again, when we close. Okay. And open it back up. Okay, now this is S. That's a lot of work just to do that, right? I mean, this is a lot of work to do this kind of stuff. This is what takes all the time in SAS to do this kind of stuff. Where, you know, in Excel, you could do it in seconds, rename the row. It's not a big deal. But in SAS, this is the hard stuff. This is the stuff I have a hard time with, is this kind of stuff. So if you do, you know, as well, it's perfectly understandable. Again, it's just what it's made to do. This is made to be a very professional system, and people spend a lot of money on it. So it does work. Okay, so now I have saved this composite data set in my folder, in my class folder. So if I look in Windows, that should be there now, right? So if I look in here, this is my folder that I did my live name statement on. Now this NAS comp is here. It says it's a SAS 7B DAT file. So that's actually the data set. Okay. So I've saved this now. So now I don't have to mess with that again. Okay. So now we've got one more cleanup step, and then we can print. The reason why we need to do a cleanup step is if we're going to make a nice graph, I want the graph to say the units, or to say a label other than S and rep and those kinds of things. So when you open this up, you just see the row name is this. And in SAS, you have a logical row name, but then you also have a way of saying what the units are, or the label. Because if this is data that we're saving for a long time, we need to know what the units are with this. We need to know, we need a name other than just S when we print a graph, okay? So I'm going to go back, and now I'm going to take the first file we made, and let's see, I'm going to do a data step. Let's take one here. And now on this one, I'm going to take the sums that I made. Okay. Make sure I get my notes right. Oh no, I see what he's doing. Sorry about that. I'm reading the notes that Paul gave me. So what we want to do is called a label statement. And so I'm going to take the file we just made, okay, and I'm going to play with a new one just to get this right. And once we get this all right, we're going to build the other one again. We're going to put it back in there. We just need to know what we're doing. So what I'm going to do is I'm going to say data, I'm going to call it NAS comp 2. Okay. And it's perfectly okay to, when you're playing around with SAS, is often what we do is we keep making new and new sets. Because I know I got something to work, but now I want to play with some new keywords and new things, and I don't know if it's going to work right. I don't want to mess up what I did, because I know that works. So let me just make a new set. So it's just kind of a SAS design trick that we do. Okay? And then once you get it to work right, you can go back and fix it. So right now I'm going to take my composite data set that I made, and now I'm going to make, oh, get my cursor out of the way, comp 2. Okay? So they can copy back and work. And I want to mess with this thing called label. And label, kind of the name implies, we'll label a column. All right, and so I'm going to say station is actually station. Okay. Just to make a label. Okay. All right, and I'm going to run that. Okay. So now I made a copy now of back the file I made, just putting it back in work, and all I did to that file is I labeled the station row. Okay, that's all I did. So I go back and work. Okay. So now it says station. All right. And here's the tricky part is that I still refer to that row as stay, S-T-A. It's just a label for station. So when you do any graph printing, it'll say station, but I still refer to the row as STA. And so I can check that when you're looking at this, and I click on the row and I right click it, and I say column attributes. So the name of the row is actually station, but the label, or the name is STA, but the label is station. Okay? So this is a new one from Excel, because you've got a logical label and then the actual name of the row.
Can you use the label in the code, or does it have to be the name?
It has to be the name. Has to be the name. Yeah. That's it. So again, this is really only for printing. This is it. The only reason why you label things is to make pretty graphs. That's it. So, and most times when I do stuff, I will work with it, just the normal names without any labels, until I get to that point where I'm actually going to produce a graph, and then produce the graph, and then just label stuff and make the labels pretty. So that's a very, like, kind of the end process. So, all right, so let me close that. And now what I want to do is I want to label everything else. And the way you do that in the label statement is you basically just keep labeling stuff and you terminate it with that semicolon so I can just keep on going. So I want to rename rep. I'm going to say replicate. And then I want to say n is equal to n 4. And we blow it up. And you notice that as I'm doing this, I'm putting things in single quotes and it's making it purple. It's recognizing that's a text string, right? So anything you do in there would be there. But if I wanted to make a single quote in the text string, then I'd have to do the double quotes on either side. Then I can put a single quote inside, right? So say if I wanted to say stations like that for some reason, like station is a person and stations stuff, and I wanted to put this in here. Now see, it just thinks station is it, and then there's some string here it doesn't understand, and then now it thinks that's a string. So the way you would do that is you have to put it in double quotes. So go ahead and put that in double quotes. So let's say stations is some guy, and stations stuff. So then that would put the one quote in there. This is the kind of stuff that really gets you when doing SAS stuff. And you spend like a few hours beating yourself up trying to figure out how to do that. Okay? So I get N for, let's see, richness. Richness per core. And I want to keep going. I also want to do abundance. At the other file because we got rid of our abundance numbers and we want them back. Okay. And so you see I've gone in extra lines. You can keep on going with this as long as you want until you get to that semicolon. So you keep renaming, you can keep renaming these. Okay? Alright. Okay. So the thing here is I actually wanted this abundance, but we don't have it in our file, right? If we go back up and look, our composite file, we didn't do the sums for that, right? We only did the sums for the number. So we want to add those into our composite file. Okay? So if we go back up to the means, that was our means statement we first did, and that gave us the sums, right? So what I want to do is I want to add now an extra variable to this. I don't want to just focus on n, but I want to focus on the nm squared. So if I look at macrofauna, I want to focus not just on this one, I also want this. I want both of them, right? So we need to find a way of telling Proc MEANS that I don't just want n, I want n, and also I want nm squared, because that's the name of the variable. So if I look up here, open this up, this was our original. Okay. So now I'm telling this means procedure we did earlier. Now let's focus on two variables. So we did one. Now again, we can add as many variables as we want. We can just keep on going. You can add 100 of them. It doesn't care. It'll do it. But now we want to output the sum. So now we need to tell it down there, not only to output the sum for n, but now I want to output the sum for nm too. Okay? So I want both of those, because now we're adding one here. Okay? So let's go back up. Now let's see what happens. Let's run this. Okay. I'm going to run the first two. So what I'm going to do is I'm going to take, again, a fresh copy. My fresh copy, I'm going to sort it, and I want it the sums now for not just the richness and not just the number of species. I want the number of species per meter squared. Okay, so do the exact same thing we did. Okay. So now when I look at it, it says, okay, work.nas now has 12 observations and 6 variables. Okay. So output nas. So now we get this. Right? So now I got to this point. We got an extra one. So you understand what it did to this variable now? Did the same exact thing. We collapsed that row and took the variables we had for number of individuals per meter squared and summed those together exactly that we did for this one. So now we have both together. And now that we have that, now we can go back and run and say, well, I want to do the same stuff that we did of cleanup, that we learned how to do now, right? I want to drop that table, the one we don't want. I want to rename the other one, and I want to label stuff, right? So if I do this and say, I want to set the one I just produced, and we produced NAS, this will just label things, right? But we want to drop the table, the one that we don't want, right? So I'm going to say drop type. Okay. Okay. And I also want to rename Okay? Just like we did before, right? So it's the same thing we did earlier, but now we know what those means. Now we know what drop and rename is, right? To get us this. Okay? So now it says we have 12 observations and 5 variables that's in this NAS2 comp. So here we go, here's the set. And then these are the labels. So if I right click on this, it should say the name of that is NM2. It should name that should be the name of the row. Right? It's just the label. It's just the printing label. Okay. But the problem is that you notice it didn't catch this when I ran it. Because I labeled S, but it didn't pick up S. Okay, it didn't pick it up, and the reason is when you do this rename, the problem is rename executes at the end of the data step, not at the beginning. The biggest problem I've ever had in learning SAS programming is the order in which you type things doesn't necessarily mean the order in which it executes. It's crazy like that. This is alien of any other programming language ever. Doesn't do that. But because they're keywords and they like run another function, it just depends on what that function does. So there's 2 ways in which we can do this. Either you do it that you create a whole nother data set to do the prepping like we did up here. And then you run the label statement down at the bottom again, a whole nother data step. Okay? Or we use some other method in which to rename the row. That'll get executed first. So there's only that's the only solution. And so again, this is why I'm saying that most times when we're working with SAS, you put just small things in one data step, and then you make a copy and you have, okay, my NAS2, and then NAS3, and then NAS4, and you do like one thing at a time. And that's perfectly okay to do stuff like that as long as it works. But another way that we could do and rename this is we could actually just say S equals like that. All right. So inside a data step, you can make any row all the time by just naming anything and saying equals. And if it doesn't come up as saying that's a key word, they can't figure out what S equals means. It thinks, well, S is going to be a new column then. And whatever is going to be in there, I'm going to put whatever's on the other side. Okay? And now we would put whatever is in frequency in S. And that should execute. Okay? So now I look back at the file. Okay. So now we got this, right? It produced S, and it ran it, and it did the label like we wanted to. But now I got a problem. Now I've got the same thing still up here because it just copied it from here. It didn't get rid of that. And so now all I got to do is now I got to get rid of that row too. So I can come back and say up here, drop type and drop frequency. All right, again, this is what throws off computer scientists more than anything. Because here, I'm putting the drop before I even do this, before I even use it. like, that doesn't make any sense to me why that would work, why that should work. The reason is because the drop and the rename execute at the end of the step. So all of this other things in here will execute first, then drop or rename at the end. So even though we've used this record name to put it somewhere, that's perfectly valid. So again, this is one of these things that really throws off people that program another language. That doesn't make any sense to me why that would work. But it's because when it looks over this data step from here to here, it says, okay, I've got these functions that need to run, and then I'm going to run whatever logic of renaming, of moving records first, and then I'm going to start executing different steps. So here's a label step, so I'll execute that. Here's a drop step, I'll execute that. Rename, I'll execute that. And so it doesn't go in order of how you actually type it up. Okay. So now if I run this, so now it says now there's 5 variables. Now we got rid of that. We've got rid of that other row. Okay. And now what I want to do is, since this is our finished one again, I want to re-save this like we did previously to our folder, right? The folder that we had, which was this right here. Because now I know that what I wrote down here works. It does everything that I did up here, right? Did everything I did up there, but also does the label statements I want, and everything's pretty. So I'm going to delete this data step that I played with at first, and this should be the good one, right? So I want to save this exactly as this. So if I do this, now I should have my set in my folder. That's pretty. Okay. And now we can print stuff. We can now get to the printing part. Because it's pretty, it's got our labels in it, it's got everything we want, right? Okay. So what I'm going to do is I'm going to actually delete this. Make it look a little bit prettier. Okay. So our whole program now sorts the file that I saved in my class file, put it out in work as macro file, took in that file, did the means by station and rep for the variables n and nm2, print out the sums for n and nm2 in that file, temporary file, took that temporary file, and then cleaned it up and put variable names and dropped the rows we don't want. Okay? So it's just a recap of that. So now we can get to printing. Okay? Because we only got like 1 minute left of class. So let me go ahead and I'm going to type this up. What we're going to do is we're going to do a Proc GLM. Okay. I'm going to type it and then I'll explain it. We're kind of running out of time. Okay. All right. So the last procedure we're going to do is going to print us out a one-way ANOVA, Proc GLM. GLM for General Linear Model. Okay. And what I'm saying is the data that we're going to bring in is this exact file, our finished file. And then I have to do these two statements. There's one called class and one called model. The class statement is similar to the by thing, But what the class really means is the x-axis. That's what we're looking for something by. So an example would be for one like a replicate or a sex or the address or something like that. That's what we want to evaluate. So what we do then is we type model, and this is our model we're going to make, our one-way ANOVA. We're going to do it by richness, and the number of individuals per core equals, I'll do this right, station. Yeah, this is, did that one wrong, sorry, right. Station. Again, we're interested in station. We're interested in, so this has to match this. So if we're interested, again, what we were looking at when we had our transects was per station, I want to see the richness and I want to see the number of individuals per meter squared. So that's going to be our x-axis on our graph like this. The x-axis is station, that's this side. The y side is going to be S, and it's going to be NM squared. So I run that. This is going to give us our graph. Okay, there we go. So when I run, so like I said, the X side, that's the stations, the class. So we get, these are the 4 stations. And this is the means of abundance. So that one of these is that's the mean, and the rest of this is the standard deviation. So it's printing out, it's using all the information from all the cores of that station, all 3. So there's a graph for that. And then above it is a graph for the richness. Same thing. Because we told it to do those 2 variables. Okay? So that's it. All that to do what we need to find out. Just per core, per station, what was the number of individuals, and per meter squared, and then the richness. So, all right, so I'm going to save that program when I get back.